Let's try another example. Here we have 1 over the square root of 1 minus x squared, and we know that 1 over the square root of 1 plus y, which is 1 plus y to the minus 1/2, has a binomial expansion. And I always like to write out the first few terms of a series to see what's going on. And now we can use substitution with y equals minus x squared to get a power series expansion for our function 1 over the square root of 1 minus x squared at 0. And again, we just write out the first few terms to see what's going on with the series. And now for part B, we just want to get a power series expansion for the integral of the previous function, so we can integrate the power series we found in part A. This is our power series expansion for 1 over the square root of 1 minus x squared. And it holds true for values of x between minus 1 and 1. And now remember, we can integrate the power series to get a power series expansion for the integral of the function, which is sine inverse of x. Now, of course, the great thing about power series is that you can integrate them term by term, just like a polynomial. So we get that sine inverse of x is the sum from 0 to infinity of minus 1 to the n, 1/2 choose n, x to the 2n plus 1 over 2n plus 1 plus some constant. Now we can determine the constant here by comparing values of the right-hand side with the left-hand side when x is equal to 0. Now when x is 0, the only non-zero term on the right-hand side is the constant itself, c, and since sine inverse of 0 is 0, then that gives us c is 0 here.